Please start your session.
Yeah, thank you. So let me share my screen.
Yes, ma'am. Just let me check it out. Your voice is not coming, ma'am. You are visible, but your voice is not coming. You are unmuted, but your voice is not coming.
So
Your
my
screen is visible to us.
okay, but voice is not coming.
Yeah, you are audible. You are audible.
Okay, I'm audible. Okay. So yeah, that good afternoon, everybody. First, thank you for
Ma'am,
joining
you are
this.
not audible.
Ma'am, you are audible. It's fine.
Okay.
Yes, ma'am, you're audible. It's fine, ma'am.
Okay. Thank you. So good afternoon, everybody. Thank you for joining this nice FDP program, like which is basically on AI and agentic AI. So we'll see today, like try to basically we'll see like what is agentic AI and what are the different components of agent and how can we build agentic system. Basically, how can we build responsible agentic system by using observability and evaluation. So that will be our focus area today. So first, all we are hearing about different AI agents, right? Like everywhere we are thinking or basically seeing or listening like for different agents, agentic system. That's everywhere. AI agents are everywhere. So what's an AI agent? Like all we know, this is an application that uses the combination of LLM capabilities, tools to the external world and high-level reasoning to basically to achieve a desired goal or state. We'll see each and every component later, like what it means or how we are going to achieve that one. So this is AI agents are nothing but a combination of all these things. It is the LLM capability, I mean the LLM, different various tools that connecting to the external world and definitely high level reasoning, planning, all these things are there to achieve the goal. So we can treat it as a whole system where LLM dynamically direct their own processes and based on the tool usage, basically control over how they accomplish the whole task. So here in this example also you can see the same thing. So agent is trying to, this is a conversational bot basically. So we have the LLM models, we have different tools from which it is accessing different information and ultimately it is giving the response to the user. So this is the main basically gist of the of any agentic system. Like three things, definitely majorly, like tool calling. Different external tools are there. Different tools are there by which we are accessing different external world things like external tool and API. Maybe we are trying to access some external URL. So basically, we have to scrap that URL and get the content that we can do by appropriate tool calling. Second thing is the memory. Like we'll see there is two types of memory: short memory and long-term memory, short-term and long-term memory. So why it is required? Like maintaining and leveraging information from past interactions. Definitely, if we have to give the proper response, we have to save somewhere the past interactions, right? Based on that, it can do the processing and give the response. So memory is another important factor. And third and most important thing is planning. That's why the agentic systems came because it can plan automatically. It's not that we have to always tell something like step one, step two, step three, not like that. We can give a complete problem to the agentic system. It will basically analyze and plan accordingly. Like first, this task should run, then the second task should run, and based on the that second task, maybe it will decide whether the third task or fourth task will run like that. Complete planning of the system will also be done dynamically. So these are the different parts of agentic system, and this is just this image basically visualizing the same. Like we can see memory, planning, knowledge, tools, and prompts. These are the different parts or different things of the agentic system, and definitely LLM is there as a brain of the system. So this is the first component, as we have seen, like a large language model that obviously should be there because, I mean, this is the core computational engine. So based on that, we can suppose we have the detailed use case. So based on the LLM only, we are asking the planning module. We are doing in the planning module like what are the different subtasks are possible from the use case. That definitely we can demystify by using the LLM. Second thing is the second component is the prompt. So again, prompts can be two types of prompt. One be general prompt and second can be specific prompt. So here in the left hand side you can see the example like the general prompt, like act as a software engineer. Your abilities are writing code, writing this file, creating this thing. So and do not finish the chain until you are sure you have the completed it. So this generic prompt can be used for different things because it is like that, mimicking the tone of a software engineer. And for the specific prompt, what we are telling, like rewrite the specific readme.file of the that specific repository, and the username is that. Like these variables are there, like repository name and username. So specific prompt will change based on the certain task, right? So general prompt and specific prompt, this can be two types of prompts. So this is the second component of the agentic system. Third component is the memory. As we have talked earlier, memory, this plays a very crucial role in the contextual understanding and retention of information over time, because it's not only like always something, it is one way, right? Like one way or one shot, like it is telling something and from the external world it is taking something and then answering. No, not always like that. Maybe just think of a conversational bot, or based on the history, it needs to process something. So memory is always required. So there can be two types of memory. One can be short term memory, like agent's train of thought. This is a dynamic repository of the agent's current actions and thoughts, like just the previous conversation, or the basically single turn or a single turn conversation, like in maybe three or four conversations it can keep it based on the demand. That is, and also it is real time, like whatever is happening in this conversation, that it can basically store. But in the long term memory, what can happen, like maybe few days before we have done some conversation, maybe few weeks or months, those history also kept somewhere. It can be definitely some database or somewhere else we can keep it. So based on the previous history, it also analyze different things and also gets the insight, so that it can respond to the user query. So based on the use case or based on the basically requirement, we have to choose whether we should go for the short term memory or long term memory, or we should use a hybrid one. The fourth component is knowledge. Like this is also very major component, because the LLM must be fine tuned to have the knowledge. We can have to create the tool to extract the knowledge, because somewhere we have to get the knowledge, right? Like we are talking about planning, we are talking about completion of several tasks. So how, from where it will get the knowledge? So definitely it can be some fine tuned LLM or SLM, or we can basically deploy some tools, or we can integrate with some tools which basically extract the knowledge from the database. So fifth component is planning. Basically, that is the starting component for many cases where it is required, right? Because when some use case or problem is given to the agentic system, first it will do the planning. Means like it should plan like what are the different subtasks which is basically coming from that agentic system, or a use case, and based on that, for every subtask they can basically deploy separate agents for that. Maybe one task can be booking a hotel, like, or doing the reservation in a hotel. So within that, what can be the different subtasks? First it will search, like in a basically given place, or given a specific place, what can be different hotels are available vacant within this time period. Then maybe between a budget it should search whether it is feasible or not, like that, three four things. So three four agents can be there. So how it will decide that how many agents will be created, that basically done by the planning module. Like it will plan what are the different subtasks, and based on that subtask it will assign the different agents for that subtask. So it can be again planning with feedback and also planning without feedback, both are possible. So, and next is the tool, another very important component. Like as we have talked, there we have to in the agentic system. Definitely, we have to access different external resources, services, or APIs that the agent can utilize to perform specific tasks or enhance its capabilities. So, then the physical tools will include the database, knowledge base, and external models. So agents can employ a rack pipeline or producing contextually relevant responses, a code interpreter for addressing programming languages, or API for conducting internet searches. So all these are different tools that agentic system can basically implement or deploy or basically access via MCP server. So till now we have seen that there are majorly six different components of an agentic system. So when we are going to build the agentic system, these six things we have to keep in the mind. Like when we are getting a use case or problem, first we need to see like the planning. We should do the planning, right? Like what are the different subtasks, and based on that we will decide how many agents will be deployed. So based on that we have to create the agent. Then we will see for when developing the agent, like what are the different tools we have to basically deploy to get the extract the outside information. That will be a part of the agent itself. So definitely memory will be come into picture, because within the agent also memory will be required, and between the agents also the memory will be required, because to keep the context, to keep different information, those will be required. And again we have seen short term and long term both memories are there. So all these modules are all these I mean parts are there, part of the agentic system. So once the agentic system is there, but we also different challenges of agentic systems are there. So difficulty in achieving optimal result in agentic pipeline. So that there can be one challenge, because agentic system is developed, but how to get the optimal results, because always we are not giving like that. So safety issues due to autonomy, because agents are autonomous. That is good, but sometimes it creates several problems, safety issues, like it is accessing several URLs, and it can search anywhere. But whether the content it is getting, whether it is harmful or not, that only that can be a security concern, right? So that safety issues are there. Trust issues due to non-deterministic output, because LLMs are concerned here, right? So and as we know, LLM always gives the non-deterministic output, so the trust issues are there. Challenges in maintaining quality and safety in output due to continuous evaluation. So, adding overhead of maintaining quality output and safety goals as changing continuously, because data are changing, so it's a ever changing environment. So, that continuous evaluations are required. Accountability issues due to multiple stakeholders in the process, optimal planning in task allocation. So, planning model we have seen, but again, we have to depend on LLM for that. So, how we'll understand the planning is optimal? That also a challenge in the agentic system. Coordination challenge. Deploying sophisticated coordination mechanism is a critical task. Achieving optimality in time, cost, and complexity. Achieving the optimal cost required continuous monitoring and these things. So these are the different challenges of agentic system. So now the question is that how to basically address those challenges. So to address those challenges, we are introducing majorly two things like evaluation and observability. It's not new, like for when we are building any system. So evaluation is very important thing, because if we don't evaluate, we cannot measure it, and if we cannot measure it, we cannot improve it. So always observe, this evaluation is a part of any system, and agentic system is not an exception of that one. And another thing is observability. Like what observability means, like it means we should continuously observe the agentic system, and we should monitor the different metrics, how it is performing. So based on this monitoring results, we can fine tune that one, we can send some alert to the user, so it will definitely improve in time. So that in that way, observability and evaluation are two important things to improve the agentic system, and it's a must in nowadays. So, as we talk, like why observability is essential. Like one thing is like definitely debugging, like simplifies debugging when building LLM agentic application. Monitor and evaluate performance. As I told, like it provides a detailed log of each call made in your application, which is very necessary to run performance evaluation. So it adds transparency and accountability in agentic system. Take necessary action ensuring safety, helps you understand and soon control the unpredictable behavior of LLM. Implementing observability framework in agentic system. So how to implement the observability framework in the agentic application? So this flowchart basically shows the same. Like in the agentic framework, first implementing observability through instrumentation. So when we are talking about implementing observability through instrumentation, we should check like whether it emits a telemetry data using open telemetry semantic conventions or not. So if it is doing, then definitely instrumentation that is already baked in, we no need to worry about. And if it is not that, then instrumentation via open telemetry. And open telemetry collector basically collects different vendor agnostic telemetry processing, and observability is backend. Observability's database is basically storing the observability data, and we can analyze the observability data. So the major thing is like observability data is traces, metrics, and logs from the agentic system in a specific format for further analysis. That is the open telemetry format. So that is the first thing. We need observability data. When observability data means traces, metrics, and logs from the agentic system. And how it need? It needs in a specific format, that is open telemetry format for the further analysis. So that is the challenge you understand, because we require data. It's not only we require data, we need a specific format, that is open telemetry. So agentic frameworks follow various conventions, and some of them offer built-in instrumentation. So data is captured in open telemetry by default, and others rely on integration with the observability tools. So hence the need of standardized and robust observability has become the need of the hour. So that observability data can be captured in the open telemetry, and it can be swept in the database for the further processing. So these are the key concept in agentic AI observability, like what is how observability data is basically stored, or how it is. So a complete visibility in every layer of LLM based agentic system, the application, the prompt response. Open telemetry is one of the widely used standards for application observability. Key concepts are like traces, spans. A trace records the path taken by request as they propagate through multiple steps. They refer to the full run through your application all the way from input to an output. Like these are the different traces you can see in the this picture. Like so in this picture, like this is the trace, right? In this trace, this is trace one and trace two. So this is one step, like the chain, retriever chain, all these things are there, and trace two. So trace is the first thing, like that is the different parts of the program, you can say, records the part taken by the request, and this propagate through multiple steps, like trace one, trace two, trace three, like that. We can run through the application from one input to the output. So next thing is the span. Traces are comprised of multiple spans. So one trace can have multiple spans. So here under trace one, you can see like LLM span is there, and another span is there, like that. So a trace is comprised of several spans, and these are the different kind of spans, like chain span, LLM call span, tool span, retriever or embedding span. So one trace consists of several spans. So, and third thing is the collector and processor. It refers to receiving or collecting traces and spans, and numerated platform for visualizing traces and run evaluations on later. So this is the collector and processor. And fourth thing is the instrumentations. Like traces and spans are captured in an application code using a process called instrumentation. So these are the data, like observability data basically. Those are captured, a process called instrumentation. It refers to marking using clauses and decorators with function, and each code blocks we collected as trace and spans with their attributes. Open telemetry's unified semantic convention aim to define how telemetry data should be collected and reported. So this open telemetry, this is the unified semantic convention. It shows how telemetry data should be collected and stored. When some agentic frameworks are built in instrumentation, they often rely on integration with observability tools. So these are the fourth thing, like traces, spans, collector and processes, and instrumentation. And again, instrumentation approaches can be two instrumentation approaches can be there. Like one is baked in instrumentation and another is instrumentation via open telemetry. So that is implementing built-in instrumentation inside the agentic framework that emits telemetry using open telemetry semantic convention. And TreeY already follows this pattern, but these are the pros and cons, like simplified adoption for user familiar with open telemetry configuration, but there are some cons also. And instrumentation via open telemetry where it is not baked in. So from the outside, basically we need to, it can be instrumentation libraries can be imported into agents and configured to open telemetry. And it also has some pros and cons. So these are the key features of agentic observability framework. So one is the, because we are talking about different observability frameworks, right? So prompt management, monitoring, tracing, evaluation, guardrail, and feedback. So these are the different key features for agent observability framework. So popular LLM agent observability frameworks are AgentOps, Arisphonics, LangFuse, LangTrace, MLflow, PortQF. These are the different observability frameworks. So till now, what we have seen, those are the observability things. Like something is running in production, but we need to capture different metrics to understand how it is performing correctly, or if any bottleneck is there. All these things we can measure by observing different metrics. That is observability. Means we are observing the current process. But another thing is the evaluation, like agentic framework for evaluation. So one is the deep learning AI approach, like there how that mentioned like how we can evaluate the agentic system. Once the agentic system is built, before deploying to the production, we can basically evaluate that one and give the score for different features. One is router evaluation, second thing is skill or function evaluation, third is path or trajectory evaluation. Like router evaluation, what happens in router evaluation? Like we talked about planning module, right? Function calling choice, did the router choose the right function to call? That is the router evaluation, like planning module. So whether it is choosing the right function. Parameter extraction, did the router extract the right function parameters from the question? Next is the skill or function evaluation. Like these are the, whether the functions are correctly evaluated, relevance, hallucination, question answer correctness, generated code summarization, all these things. Path or trajectory evaluation, measure and calculate convergence. So these are the path or trajectory what is taking, that is evaluate correctly or not. Second approach is Raga AI Catalyst. How they are doing, like they have four metrics: tool utilization efficacy, memory coherence and retrieval, strategic planning index, and component synergy score. So tool utilization efficacy, whether the tool is utilized properly, memory coherence and retrieval is proper. So these are the four metrics by which we can evaluate the current agentic system. So this is the Raga AI approach. So these are the different calculations, and you can see all these things the Raga site. So how the tool utilization efficacy is calculated, how memory coherence and retrieval is calculated. So all these things you can access in the Raga's framework, Raga's AI, this site. So another approach is multi-agentic evaluation system. So till now, what the evaluation system we have seen, these are majorly for single agent, because we are evaluating different things in the agent itself or agentic pipeline. But here in the multi-agentic system, we'll more concentrate on how different agents are communicating with each other. So the metrics will also differ, because metrics for evaluation will be cooperation and coordination, because agents need to collaborate to each other, and how different agents are communicating in between or among them. And also tool and resource utilization, that is same, and scalability, how we can add more agents in the system. So you can see here, this is the difference between evaluating the multi-agent system. Here we are incorporating two important metrics, that is cooperation and coordination and scalability. Those are the specific features are specific to the multi-agent system. So multi-agent system, evaluation system, how to build, like agent integration logs, track every decision, action, and communication for analysis. Such logs can contain timestamp, tool call, generated result, or internal conversation. Evaluation metrics, like define metrics and benchmark for agentic interaction. Once the logs are ready, it's time to decide what to evaluate. An evaluation framework, choose the right framework to start evaluating the using. So multi-agent evaluation system, these evaluation metrics are very important. That is for collaboration, tool utilization, output quality, system performance, and ethical metrics. And these are the different metrics and their description. Like collaboration consists of task, allocation accuracy, communication latency. Tool utilization basically consists of tool success rate, adoption rate. Output quality consists of output coherence, system performance like the throughput or fault recovery time, ethical metrics like fairness, and these are the different metrics for evaluation. And these are the till now we have talked about different how we can evaluate different agentic system and their metrics. And these are the different frameworks available in public by which we can use to evaluate the agentic system, like deep eval. Evaluate LLMs with customizable metrics and task data centric focus. We have TrueLens that also focused on interpretable alignment of outputs, ragas, and deep checks. So brain trust, like agent evaluation strategy. So these are the generic metrics for evaluation, like behavioral pattern, tool effectiveness, cost efficiency. Granular metrics for evaluation are route accuracy, downstream task quality, step limit check, and task success rate. So another agentic framework evaluation approach is ISAR approach, where this is a little bit detailed, like cost, optimizing resource utilization, how we are doing, like infrastructure and operational cost, scalability cost, cost per task, latency, like ensuring timely responses, like time to first response, reflection latency, throughput, accuracy, like delivering reliable output, task completion rate, state level accuracy, precision and recall, reflection, security, protective sensitive information like threat detection rate, session management, stability, like maintaining consistent performance, response consistency, execution error rate. Yes, like we have seen like the different two things majorly, like what is the agentic system? Majorly three things: agentic system. Second is like the observability, like how we can observe different metrics when the agentic system is running in the production, and how we have to evaluate that one. So, if any specific question is there on this one or anything, we can address now. Yeah, the floor is open for any questions, please. I can address. Any question from anybody? Yeah,
You
please.
can type in the chat box also. Currently, there is no question, ma'am, so we can move
Okay.
forward.
Okay. Yeah, I have completed. I have completed what I want to for today's one, like the agents evaluation and observability.
Okay.
So, if any
Directly,
question?
you can send the message to ma'am or me also. There is one question on my end. What are the differences between the generative AI and agentic AI?
Yeah, so generative AI basically it's a broad term. Like everything comes on the generative AI. It's majorly based on the LLM based system. So like till date, what not till date, a few months ago, what we used to do, like we have the LLM, we are asking different questions and getting the answers. So, but the thing is that when we are accessing information from different sources, we need to plan, and also we don't know the environment, how the environment is and how it is changing based on the environment, so you understand it will be little bit complicated. So that's why agentic system comes into the picture, because we have several features that we have seen in today's session. Like one is the planning. Like by the planning, we can understand what are the different tasks we need to perform based on the use case. So we can take help of planning. And also there are tool callings are there, different tools are there, so that we can call different tools based on the need. And also you have memory, so that we can store the requisite things, and based on that we can generate the response. So all these things are present in the agentic system. It's not only a LLM. So that we can basically address any use case in a much more effective way. So that's basically difference between agentic AI and generative AI.
Thank you, ma'am. There is another question uh, that in the light of generative AI, how can we guide our students for the research orientation?
Yeah, so if you ask me about the topics, so I suggest like topics or the learnings, the deeplearning.ai. That is a very nice site, and we all know like Andrew NG is there. Like those sessions are, or basically the videos are from deep learning, that maximum created by Andrew NG and his colleagues. So there we can go and get the short courses. All the things are free, and we also learn from there. There itself we will get very nice research topics. So a few basically research topics are like SLM fine tuning, sovereign AI. It can be responsible AI. It can be age AI. So these things are very popular basically, and we can definitely recommend for research.
Thank you, ma'am. Ma'am, there is another query that in recent learning phases, in recent times, there are AI tools are used basically to check the grammatical mistakes and framing of the sentence also. So, at is the AI phrases tool will also cover the Turnitin or the authenticate databases?
Yeah, it depends basically. Covering depends on basically access, permission, and all these things. So normally LLMs are trained on the materials which is public, ideally. Okay, because it should not access any database which is restricted. So if it is public, ideally it should access, but if it is restricted, then ideally it should not access that database.
Thank you, ma'am. Ma'am, there is another chat that there is another query that whether is there any differentiation between the subscription and non-subscription version of GPT and other LLM models?
Yeah, definitely it is there, because if it is a subscription, better LLM models are used in the background. Okay, they are trained better, and they are basically more fine-tuned models are there, better trained LLM models. So you will get better output, better result, that we have seen.
So is it very ethical also if the LLM model will be better? In that case, definitely few of the terms we will try to use using this. But in writing of the paper, definitely the plagiarism or AI paraphrased content will be coming in that way.
Yeah, so ethical means, see, definitely for paper writing, somebody first do the research and do the POC, right? There should not be anything like we should not generate by ChatGPT and it will not come. The experiment should be performed first for any POC or anything. But definitely when writing some grammatical mistake, maybe somebody is writing the experimental setup. So once it is written, once the experiment is done, somebody has written it, so you can use the chat gpt to just correct the errors or make the sentence better. I believe that is fine, but definitely it will not generate the experiment. That should be done properly, that should be documented properly, everything. So there should not be any ethical issues.
Okay, thank you, ma'am. Ma'am, there
Thank
is another query is there for
Yeah.
specially coding purpose, or is there any choice of any different generative AI model?
Gemini is best for coding and all this. More specialized coding things are there, but those are that subscription is required. But Gemini we can use, because we also use Gemini for code generation and this thing. These are pretty decent. We can use it.
Okay, thank you, ma'am.
Thank you then.
Yes, there are no more questions from my side. I'm requesting all the participants also. If you have any question, you can write, you can raise your hand, I can unmute, you can directly ask our speaker if you have any query. Okay, I can't find any more query here. Thank you, Anindita ma'am, once
Thank,
again.
thank you. Thank you.
Yes,
Okay.
yes, ma'am. I'm
Bye.
requesting all the participants to kindly give your attendance. Thank you all.